Hey everyone, Morgan here. So today we're going to be talking about phase changes and the behavior of particles. Now you can't see particles. You can't see water in the gaseous phase. So what we're going to be using here is an element called bromine. Now this device is called a cryophorus, and it is filled with liquid bromine. A little bit about how this was made. The bromine was put down here into the bottom, and it was frozen using liquid nitrogen. Then up from here, we pulled a vacuum. We got all of the air out of the cryophorus. We sealed it off while it was still frozen bromine. And as it warmed up, the bromine first melted, turned into the liquid, and then it evaporated, turned into the vapor. And this brown cloud that you're seeing is bromine gas. This is clear glass. You can see straight through it when there's not something in it, okay? But the deepness of the color is an indicator of the concentration of the bromine gas. There's quite a bit in there, and you can see this nice little pool of the liquid bromine there. So what I'm gonna do is I'm gonna make this really cold really quickly. This is liquid nitrogen. It is boiling at about 196 degrees below zero on the Celsius scale. And I'm gonna bring this up over this, and we're gonna allow it to get very cold. So if you focus up here on the bulb up top, what you're going to see is the bromine gas lowering in concentration. It's flying down here to where it's very cold. And when it happens to get down into there, it's gonna go from the gas to the liquid to the solid really quickly, okay? Now we have a pool up here that's behaving really interestingly. It freezes across the top first because evaporation is a cooling process. So the liquid bromine evaporating off, okay, goes down here, and then the liquid that's below the top where it freezes breaks through, okay, because it vaporizes. Now the reason the bromine up here in the liquid phase is vaporizing is because we're decreasing the pressure inside this bulb by lowering the temperature and taking all of that gas out of the gas phase and getting it into the liquid phase. So this looks pretty interesting now. We have clear glass, you can tell. We have solid bromine there, solid bromine here, okay? It's kind of an orangish color when it's in the solid phase. A bit of a collection of liquid bromine right there. That's the dark red color. More solid up here. But take note, this through here is brown again, isn't it? That means that some of the bromine is ending up back into the vapor phase, okay? It can do that because I've taken the cold away. There was a vacuum in there. The only pressure that was being exerted were the bromine molecules in the gas phase that are flying around and hitting the walls of the container. So when I take them away, the pressure goes down, so we get boiling at reduced pressure. As it warms up, more and more of the bromine is going to end up back in the gas phase. Now one thing I can do this very gently, is I'm going to loosen this clamp here, and I'm going to rotate this like that, clamp it down again. And given some time, what you're going to see is this bromine start to melt, and it'll dribble down. It looks a little like blood when that happens because of the dark red color. Now over here, you saw that big solid chunk, well, it fell down already. All right, I went to the other side. So I can take my hand and just warm this up very slightly, okay? These are not cryogenic temperatures anymore. I took the liquid nitrogen aside. bring my hand up here. Gently start to warm that. It feels cold to me, but it feels cold like taking a bottle of soda out of the refrigerator, or one that's really cold that's been in a cooler with lots of ice. Warm up here. Ice has formed on the outside here. Very, very thin layer. We have some humidity in the classroom today. Little warmth to help that get started. So what I'm going to do now is step away for a second, and we're going to allow this to melt. And when you actually see it in the video, you're going to see it as time-lapse, okay? And then when I step back in, it will have been about 5 or 10 minutes later. Let's watch this now. Hey everyone, I'm back. So it's been somewhere between 5 and 10 minutes, and what you have been seeing here is that the deep red color, orangish to red color that you saw up there, is disappearing. The bromine has been melting and vaporizing. You can see the very rich red color, almost looking like blood, that's dripping down inside, okay? Occasionally you can see a spot, okay, where it is kind of stuck, right? It's been a humid day, quite a bit of condensation, okay? At first it was deposition, now condensation. There we go, nice big chunk just broke loose and fell down. So what I'm gonna do is I'm gonna rotate this again. Switch it back over this way, tighten it down. And you can see from the movement there, we have a whole pool of liquid bromine again. We have a nice cloud up there. Try and get some of that condensation off, okay? Give it a little bit of warmth, and that causes just a little bit more of it to evaporate, okay? It's technically not boiling, it's evaporating. We'll talk about that later in the year, okay? So again, this is called a Bromine Cryophorus. I've actually seen references to this demonstration that date back all the way to the 1880s. It's a really great demonstration. Before liquid nitrogen, what they did was they would put water soaked and then alcohol soaked towels on top of this and allow the alcohol to evaporate. And then they switched over to a mixture of dry ice and alcohol, which got really cold also. Now with liquid nitrogen being readily available at any welding store, okay, it's much faster to do it this way. Okay, thanks for tuning in. Hope you've enjoyed this. Have yourself a good day. This is Morgan signing off.